Fibonacci series with integral calculus. Fibonacci series with integral calculus. This is the discussion that we are pursuing. And as I have said, that I have seen people taking PhD degree in manipulation of Fibonacci series. And here there is a new invention in calculating the summation series in Fibonacci series, and that is through calculus way. Anyone is open to take PhD degree from this research. Okay, all possible computation in Fibonacci series can happen through integral calculus. And how it can happen through integral calculus? This is what we are demonstrating, and this is first of its kind. This has never been seen, at least I have not seen any book anywhere where we can do series summation through integral calculus. This is a very fantastic way to convert a discrete function into continuous function. Once discrete function is converted into continuous function, then after that, then it can be manipulated. Continuous function can be used in integral calculus. Integral calculus cannot work on discrete function, and summation and series works only on discrete function. If I have been given a summation and series, then unfortunately it works only in discrete function, whereas integral calculus works only in continuous functions. So there is a fantastic way to convert discrete function into integral function and then into continuous function and then continue with the integral calculus. We are taking a summation and series of Fibonacci series. As we have said, Fibonacci series is nothing but count of bacteria on a particular day. When I know a bacteria can divide on its own into two. If there is a child bacteria on day number 1, then day number 1, day number 2, it will not multiply day number 3 onwards every day. Once it will multiply into 2. In that manner, if there is a child amoeba, not bacteria, amoeba. If there is an amoeba can divide into 2. If amoeba is born today, then it will take today and tomorrow to get matured, and third day onwards it will start multiplying into 2 and 1. It does only once in a day. If this happens in that way and I'm bringing a child amoeba today, then today, tomorrow, and day after tomorrow, it will start multiplying into 2 every day once, and it will generate a Fibonacci series. Okay, what about the amoeba on day number X? Amoeba on day number X is amoeba on day number X minus 1. Because amoeba are not dying, so X minus 1 amoeba, day number X minus 1 amoeba, they will proceed upon day number X also, and day number X minus 2 amoeba, they will be matured for 2 days on day number X, and all will reproduce, all will divide into 2. Fx, that is the amoeba count on day number X, is Fx minus 1 plus Fx minus 2. Makes sense? Fx minus 1 on the last previous day, whatever the amoeba count is, they will proceed through on day or on today also. And day before yesterday, whatever the amoeba count was, exactly same number of amoeba they will produce today, because all are 2 days old at least. So in that manner, amoeba on day number X equal to amoeba on day number X minus 1 plus amoeba on day number X minus 2. We also represent this as function over X, f in bracket X. This also can be written as u bottom right X, ux. Fx function over X, f and bracket X bracket close, or u bottom right as subscript X, ux. Ux means number of amoeba on day number X. What is your amoeba series? What is your Fibonacci series? U1, U2, U3, U4, U5. These are Fibonacci series. U10 means number of amoeba on day number 10. What is U1? 1, U2? 1, U3? 2. On third day, it is multiplying into 2. U4? 3, U5? 5, U6? 8, U7? 13, and so on. Okay, now we can also describe the amoeba on day number X as 5 to the power X minus 5 to the power X. Hope I'll rephrase it. phi 1 to the power x minus phi 2 to the power x by a square root of phi, where phi 1 is 1 plus a square root of phi by 2 and phi 2 is 1 minus a square root of phi by 2, which is always negative. Now, if it is negative, 1 minus a square root of phi by 2 to the power x, if x is even number, then the whole will become positive, and x is odd number, whole will become negative. Outside negative is waiting. So we can rephrase it as consider a equal to phi 1, a equal to 1 plus a square root of phi by 2, and b equal to 1 minus a, sorry, b equal to a square root of 5 minus 1 by 2. B is always positive. Means a equal to phi 1 and b equal to minus phi 2. In that manner, I can say amoeba count on day number x, fx equal to ux equal to a to the power x plus b to the power x by a square root of 5 if x is odd number, a to the power x plus a to the power x minus b to the power x by a square root of 5 if x is odd, x is even number. If it is even, it is minus. If it is odd, it is plus. A equal to phi 1 equal to 1 plus a square root of 5 by 2. B equal to minus phi 2 equal to a square root of 5 minus 1 by 2. Okay, so these fundamentals we will take. And now we are calculating for a hybrid Fibonacci series. A hybrid Fibonacci series. And that is U1 into U1 plus M, where M is a variable. Any variable. M can be 1, 2, 3, 4. We have already done for M equal to 1, M equal to 2, and M equal to 3. Means U1 into U1 plus, means in new Fibonacci series it is U1. I'm sorry, it is U1 into U2, where M is 1, then U1, U1 plus M. M is 1, then U2. U1 into U2, U2 into U3, U3 into U4, and so on. UN plus 1. We have already calculated this, and it comes as UN plus 1, UN plus 1. For n as odd, UN plus 1 into UN plus 1 minus 1. For n for even. U1, U3, U2, U4, U3, U5, U4, U6, and so on. UN plus 1. Okay, in that matter, if n is odd number, it is UN plus 1, UN plus 2. If n is even number, UN plus 1, UN plus 2 minus 1. Then we calculated U1, U4, U2, U5, U3, U6, UN plus 3, where M is 3, and it comes as UN plus 1, UN plus 3, if n is odd. Everywhere UN plus 1 is there, everywhere. UN plus 1, and right hand side in the result. Right hand side it is varying, depends upon the M. If M is 1, then UN plus 1, UN plus 1. If M is 2, UN plus 1, UN plus 2. If M is 3, UN plus 1, UN plus 3. If n is even number, then UN plus 1 into n plus 1 minus 1. UN plus UN plus 1 into UN plus 1 minus 1. UN plus 1 into UN plus 1 minus 1. UN plus 1 into UN, sorry, I'm sorry, I'll re-say the kind of the result. UN plus 1 into UN plus 1 minus 1 if n is positive number. N is even number. UN plus 1 into UN plus 2 minus 1. UN plus 1 into UN plus 3 minus 2. On the 2, it is minus 1, minus 1. Here it is minus 2. Looks like it is equal to UM. The summation of U1 plus M. U2 plus M, U3 into U3 plus M up to UN plus M is Fn plus 1 into, sorry, UN plus 1 into UN plus M minus UM. Okay, if M is 1, we are getting for n as even number. If n is odd, then UN plus 1, UN plus M. This is what we have already proved. If n is even number, then it is UN plus 1, UN plus M minus UM. Where M is 1, then minus UM is minus 1. When m is 2 minus um is minus 1 again. When n is 3 minus is minus 2. Now, can I expect if m is 4, then minus will be minus 3. If m is 5, minus will be minus 5. If m is 6, minus will be minus 8, and so on. Can someone prove it? These are very intricate proof in Fibonacci series, and we will do it through same way for successive approximation in integral calculus. The first concept is what is ux at on any day x, what is number of amoeba. If it is a pure Fibonacci series on any day x, number of amoeba is ux. If x is odd, it is a to the power x plus b to the power x by a square root of 5. If x is even, a to the power x minus b to the power x by a square root of 5. Understandable? Now, we are trying to have a hybrid Fibonacci series where x day it is ux into ux plus m. On nth day it is un plus m. Now compute the summation of this Fibonacci series. Okay, we have gone very far. Many times we have demonstrated what is our successive approximation is. Successive approximation is a way to convert a discrete function into continuous function. If this is x-axis, then consider this is origin. If this is origin, this is 1, this is 2, this is 3, this is 4. These are the indexes on x-axis. This is y-axis. If this is y-axis and this is x-axis, x equal to 1, then this is y or fx or ux. X equal to 2, x equal to 3, x equal to 4, and so on. X is along this direction and fx is along this direction. At any x, fx is ux into ux plus m, m for monkey. Okay, so this is how it is. Now, if this is the case, then how we can compute up to un plus m, where n is even number. For odd we have calculated, and it is un plus 1 into un plus m. If it is even number, then n is even. Then okay, if n is even, then now whatever x we have x from 1, 2, 3, 4 up to n, where n is even number. If n is even number, then odd number is 1 less than that. That is n minus 1. Up to n minus 1 odd number is there. Up to n even number is there. 1, 2, 3, 4. 4 is the end. Then odd number will be 1 less than that. That is 3. N is the end, that is even. Then odd will be n minus 1. Understandable? Now, in that manner, we will start now. So, how to convert a discrete function into a continuous function? Discrete function is ux into ux plus m. That is defined only at x equal to 1, 2, 3, 4, not continuous manner. That is fx. This is fx. Okay, this is gx. Consider this is another function called gx, and this is a continuous function. If this is a continuous function, this function is valid. This function is defined at any fraction of x also, and this is gx. What is gx equivalent of fx? That is a question mark. Okay, anyway, fx is ux into ux plus m. That is again different for x is even or odd. If it is even, then ux is a to the power x minus b to the power x by 2. If it is x is odd, a to the power x plus b to the power x by 2. Makes sense? Now we will segregate our problem into two parts, x being odd, x being even. If it is odd, then I have indexed on x-axis and x equal to 1, 3, 5 up to n minus 1. If it is even, then it is 2, 4, 6 up to n. Now let's convert first the odd number into a continuous function. So odd, okay, what we want, as I always say, what we want is summation sigma sign x equal to 1 to n, where n is even number, fx plus fx plus fx plus fx plus fx up to x equal to n, start from x equal to 1. Fx equal to ux into ux plus m, u1 plus m, u2 plus m, u3 plus m, and un plus m. u1 is 1, u1 plus m I don't know, depends upon m, but I have to find result in term of m1. Okay, We have already done for m equal to 1 to 3. Now we will do for m equal to m. Make sense? Now this is how it is. Now if I take only odd number, then x equal to 1 to n minus 1 fx, where fx is at x equal to 1, 3, 5, 7 up to n minus 1. At any x, it is ux plus m, where ux is x is odd, a to the power x plus b to the power x. Consider m is even number. I'll try for odd also. For 1, I'll try for odd also. But right now, I'm taking m as even. Again, it will change. If m is even, x is odd and m is even, then x plus m will be odd again. So ux plus 2 will become a to the power x plus b to the power x. A to the power x plus m plus b to the power x plus m divided by square root of 5, a square root of 5. Makes sense? Okay, if I multiply these two terms, it will become a to the power 2x plus m plus b to the power 2x plus m plus a to the power x b to the power x in bracket a to the power m plus b to the power m. A to the power x b to the power x is a b to the power x. A into b is 1. A is 1 plus a square root of 5 by 2. B is a square root of 5 minus 1 by 2. Multiplication will be 4 minus 1 by 4. 5 minus 1 by 4, that is 1. So net ux plus m is a to the power 2x plus m plus b to the power 2x plus m plus a to the power m plus b to the power m. This is fx at any x. Now, if I'm talking about fx at any x, okay, if this is x-axis and x I have taken in only odd, x equal to 1, x equal to 3, x equal to 1, I have fx, that is u1 plus m. At x equal to 3, I have u3 into u3 plus m. If I have these two, x equal to 1 and x equal to 3, if I go up, then it makes an area, and this area goes and hit gx. Okay, means gx dx from x equal to 1 to x equal to 3, this area is exactly same as left hand side fx, means I'm forcing it to be same. If it is same, then all the summation of all the fx will be same as summation of right hand side gx area. Means if I compute gx full area, it will give full summation of fx. Makes sense? This is the invention. This is the invention can be patented. Means many people can get PhD degree in mathematics from this invention. I am sure about it. This is very powerful invention. Anyway, now what we have, fx equal to x equal to x, fx equal to x, fx at x equal to x is a to the power 2x plus m plus b to the power 2x plus m plus a to the power m plus b to the power m. That should be equal to, if that is the concept we are applying for gx, that should be equal to x to x plus 2 gx dx, because everywhere sampling is happening at 2 gap, because we are taking only odd. X to x plus 2 gx dx, fx equal to limit x to x plus 2 gx dx, where fx is a to the power 2x plus m plus b to the power 2x plus m plus a to the power m b to the power m gx dx. In previous session we have already done it, and gx fx equal to gx dx, gx equal to dfx by dx. In that manner, it will come at 2 log a to the power 2x plus m plus 2 log b to the power 2x plus m plus 0. That is gx. If I integrate with dx, then 2 log a, 2 log b will go away. Integration is x to x plus 2. That will come as a to the power 2x plus 4 plus m. Makes sense? Minus a to the power 2x plus m. I can take out a to the power 2x plus m. It will come as bracket a to the power 4 minus 1 plus b to the power 2x plus m b to the power 4 minus 1. I can take gx now. This is successive approximation. Take gx something, integrate x to x plus 2 and see if it is equal to fx. If it is equal, not necessarily it is x to x plus 2, it can be anything. In this scenario, it is x to x plus 2 because it is gap is 2. Someone can take x minus 2 to x also, left hand side area. Someone can take central area also, x minus 1 to x plus 1. If division is happening in 2. If it is happening in point 1, then x to x plus zero point 0.2, like that. Not necessarily we will take x to x plus 2 only. Anyway, now if I do so, then how much? Consider g. Okay, if I had taken gx as the beginning, 2 log a to the power 2x plus m plus 2 log b, a to the power 2m, a to the power 2x plus m, x to x plus 2, then we saw it is multiplied by again a to the power 4 minus 1, b to the power 4 minus 1. We have to retake gx new, and gx would be 2 log a into a to the power 2x plus m by a to the power 4 minus 1 plus 2 log b a to the power b to the power b to the 2 log b to the power 2x plus m by b to the power 4 minus 1 plus a to the power m plus b to the power m by 2. That integration will be multiplied by x plus 2 to x 2 to go down a to power. So gx with the successive approximation, start gx with dfx by dx, and that will be 2 log a to the power 2x plus m plus 2 log b a to the power 2b plus m 2x plus m. Then we saw that dx that is coming is a to the power 2x plus m into a to the power 4 minus 1, b to the power 2x plus m, 2x plus m into b to the power 4 minus 1 with limit x to x plus 2, means a to the power 4 minus 1, b to the power 4 minus 1 is extra, and a to the power m plus b to the power m is not there. If I reshuffle it, then we get gx as 2 log a into a to the power 2x plus m by a to the power 4 minus 1 plus 2 log b to the power 2x plus m by b to the power 4 come down minus 1 plus a to the power m plus b to the power m whole divided by 2. If I take this as gx, integration with dx and x to x plus 2, it will come exactly as fx, a to the power 2x plus m plus b to the power 2x plus m plus a to the power m plus b to the power m. Now to compute this is for odd x, odd x. If I take for even x, then even x, ux plus m, ux will be a to the power x minus b to the power x, ux plus m, where m is even, then it will be a to the power x plus m minus b to the power x plus m. If I multiply a to the power 2x plus m plus b to the power 2x plus m minus a to the power m minus b to the power m. Only minus will come at the end. Anyway, now to compute the summation for all the odd x equal to 1, 3, 5 up to n minus 1. N minus 1 area strip will be n minus 1 to n plus 1, 2 gap. So last will be n plus 1 in the integration, minimum to maximum. For even number, it will start from 2 and it will go up till n, because n is even. Last sub area will be n to n plus 2, 2 to n plus 2. So it will be, to get the odd number summation, it will be limit will be 1 to n plus 1. For even number summation, it will limit will be 2 to n plus 2. Makes sense? Now 1 to n plus 1 fx dx, this will give the odd summation u1 plus m, u3 plus m, u5 plus m, u7 into u7 plus m up to un u1 un minus 1. For even number gx dx from 2 to n plus 2 will give even summation. If I add both, we get the result. Okay, we'll do so. So f gx dx integration, if I do, then 2 log a will go up. A to the power limit is 1 to n plus 1 for odd. Then a to the power 2n plus 2 plus m minus a to the power 2 a 2m 2 plus m, a to the power 2x plus m, x is 1, then 2 plus m. If x is n plus 1, then 2n plus 2, a to the power 2n plus 2 plus m minus a to the power 2 plus m divided by a to the power 4 minus 1. A to the power 4 minus 1 is a square minus 1, a square plus 1. A square minus 1, a is 1 plus a square root of 5 by 2. Then a square minus 1 will come as a only, 1 plus a square root of 5 by 2 only. Means a to the power 4 minus 1 is a into a to the a square plus 1. A is there on numerator, I can take out a to the power 2n plus 1 plus m minus a to the power 1 plus m. A is out, a cut down each other. This is how it is. Now from b also we can do same thing. B to the power 4 minus 1 is b to the b square minus 1, b square plus 1. B square minus 1, where b is the square root of 5 minus 1 by 2, will be minus b. Okay, if I do minus b, then it will come as minus there. Okay, now it will come as a to the power 2n plus 1 plus m minus a to the power 1 plus m. Makes sense? And then minus b to the power 2n plus 1 plus m plus b to the power 1 plus m. This is divided by b square plus 1. This is divided by a square plus 1. Okay, plus a to the power m, b to the power m x 1 to n plus 1, that is n. So a to the power m plus b to the power n m by 2 whole multiplied by n. Makes sense? Now for even number, limit will be 2 to n plus 2. So it will be a to the power 2n plus a to the power 2n plus 4 plus m minus a to the power 4 plus m. 2x, x is 2, 4 plus m. I'll take out a to the power 2n plus 3 plus m minus a to the power 3 plus m. Divide by 1 plus a square. A will go away. Similarly, minus in b. And last is minus, and then in bracket a to the power m plus b to the power m by 2. Limit is 2 to n plus 2. N plus 2 minus 2 is n, and minus. So this minus and this plus, they will completely take it out. And it will become a to the power 2x plus 1 plus m minus a to the power 1 plus m plus a to the power 2n plus 3 plus m minus a to the power 3 plus m. I can take out a to the power 2n plus 1, 2n plus 1 plus m as common factor, 1 plus a square, minus a to the power 1 plus m, again 1 plus a square, 1 plus a square, 1 plus a square would go away. And at the end, it will come at a to the power 2n plus 1 plus m minus a to the power 1 plus m. Similarly, for b also it will result in same thing. Minus b to the power 2n plus 1 plus m plus b to the power 1 plus m. That's it. This is the result. A to the power 2n plus 1 plus m minus b to the power 2n plus 1 plus m. Make sense? Minus a to the power 1 plus m plus b to the power 1 plus m. What result we are expecting? Actually, someone can break it into big and result can be proud. But for brevity, I can see if it is matching to the expected result or not, because it will not be very nice to go for very big explanation. What is the expected result? It is a n plus 1. It is u n plus 1 u n plus m, u n plus 1 into u n plus m minus u m. Un plus 1, where n is even number, then n plus 1 is odd number. If n is even number and m is also even number, then un plus m, n plus 1 is even number. Multiplication will come as a to the power n plus 1 plus b to the power n plus 1 into a to the power n plus m minus b to the power n plus m. Makes sense? Divided by a square root of 5 into square root of 5, that is 5. A square root of 5 division, we have discarded it into the calculation deliberately so that it will become easy. So the result is a to the power n plus 1 minus b to the power n plus, a to the power n plus 1 plus b to the power n plus 1 by a square root of 5 into a to the power n plus m minus b to the power n plus m by a square root of 5 minus um, where m is even number. So um will be a to the power m minus b to the power m minus, and in bracket a to the power m minus b to the power m. Understandable? Okay, now this is how it is. If I multiply these two terms, a to the power n plus 1, a to the power n plus m, a to the power 2n plus 1 plus m, this is what we are getting. Okay, next is minus this side we have b to the power 1 plus b to the power n plus 1, and that side minus b to the power n plus m minus b to the power 2n plus 1 plus m. This is what we are getting. Exactly. Okay, last one is little bit elusive. Okay, so last one is now a to the power n plus 1 minus b to the power n plus m plus plus b to the power n plus 1 a to the power n plus m. Means if I take out a to the power n plus 1 b to the power n plus 1 as common factor, it will come as a to the power m minus 1, b to the power n plus 1, b to the power n plus 1, a to the power n plus m. If I take a to the power n plus 1, b to the power n plus 1 as common factor, so from a to the power n plus 1, if I take out a to the power n plus m, if I take out a to the power n plus 1, remaining will be a to the power m minus 1. So it will come as more or less, it will come as a to the power n plus 1 b to the power n plus 1 in bracket. Okay, in bracket it will come as a to the power m minus 1 minus b to the power m minus 1. A to the power n plus 1, b to the power n plus 1 is ab to the power n plus 1. Ab is 1, so 1 will go away. So it will become a to the power 2n plus 1 plus m minus b to the power 2n plus 1 plus m, and then then a to the power m minus 1 minus b to the power m minus 1. This is what the result we are getting. Understandable? Plus a to the power m minus 1 minus b to the power m minus 1. What this is the expected result. A to the power 2n plus 1 plus 1 plus m minus b to the power 2n plus 1 plus m plus a to the power m minus 1 minus b to the power m minus 1. What we are getting? A to the power 2n plus 1 plus m minus b to the power 2n plus 1 plus m. This is what exactly we are getting. But next what we are getting is completely different. Anyway, in the result, one thing that is missing, whatever we are saying, divide by 5 minus um minus, and in bracket a to the power m minus b to the power m divided by a square root of 5, that is also there. If m is even number, if n is even number, m even number we have already taken. What we are getting in the result is, I'll rephrase what is expected, what we should get in the result. A to the power 2n plus 1 plus m minus b to the power 2n plus 1 plus m plus a to the power m minus 1 minus b to the power m minus 1 whole divided by 5. Square root of 5 into square root of 5 is 5 only, minus, and then in bracket a to the power m a to the power m minus b to the power m divided by square root of 5. This is what is expected. What we are getting? A to the power 2m plus 1, a to the power 2n plus 1 plus m minus b to the power 2n plus 1 plus m. This is exactly same we are getting. Then we are getting minus a to the power m plus 1 plus b to the power m plus 1 by 5. We had left 5. This is what we are getting. That's it. Okay, now expected is a to the power m minus 1 minus b to the power m minus 1. What we are getting is minus a to the power m plus 1 plus b to the power m plus 1. Very different, right? Okay, now we will say, no, we are getting same thing. My sentiment is saying, okay, write it. Who is stopping me? A to the power 2n plus 1 plus m minus b to the power 2n plus 1 plus m. It is already there. And in result, it should be plus a to the power m minus 1 minus b to the power m minus 1. Okay, if I am adding this from my side, then I have to subtract in that manner only. If I subtract, then it will become minus a to the power m minus 1 plus b to the power m minus 1. And earlier we had minus a to the power m plus 1 plus b to the power m plus 1. Whole thing will be extra, but we are getting the result. So I can say we have got the result. un plus 1 into un plus m. Result is there. Plus result is already there. Un plus 1. Okay, un plus 1 into un plus m. That is a to the power 2n plus 1 minus 1 minus m minus b to the power 2n plus 1 minus m plus a to the power m minus 1 minus b to the power m minus 1 by 5. Result is there. Okay, but extra thing is there now. That big thing is extra that we have to compute. And what the extra is? Extra is now what we are getting is minus a to the power m minus 1 minus a to the power m plus 1 plus b to the power m minus 1 plus b to the power m plus 1 whole divided by 5. And this should turn into minus in bracket a to the power m minus b to the power m by square root of 5. Now someone can try. Okay, I have personally tried it and it works. Okay, it will exactly come as minus um. Someone can try, take it as an assignment. Okay, little bit we can proceed, no one is stopping it to proceed. In the result it is minus, it is in result it is minus a to the power m plus b to the power m by a square root of 5. This is the result. Or minus in bracket a to the power m minus b to the power m by a square root of 5. Or I can say it is plus b to the power m minus a to the power m by a square root of 5. Here also similar thing is there. B to the power m plus 1 plus b to the power m minus 1 minus a to the power m plus 1 b to the power m minus 1 by 5. It should be a square root of 5. 5 is actually a square root of 5 into a square root of 5. Anyway, we will take out a to the power, we will take out b to the power m, a to the power m outside. So it will become b to the power m and then what, then b plus 1 by b. B to the power m plus 1, if I take b to the power m outside, b to the power m minus 1, 1 by b. It will become b to the power m bracket b plus 1 by b by a square root of 5. We have broken 5 into a square root of 5 into a square root of 5. A square root of 5 is wanted one. Another square root of 5 is unwanted. Means we have to show now that b plus 1 by b by square root of 5 is 1 somehow. If it comes 1, then it is alright. Next is minus a to the power m, and then in bracket it will come as a minus 1 by a plus 1 by a by a square root of 5. We'll try one. A plus 1 by a by a square root of 5 is 1. Okay. A is 1 plus a square root of 5 by 2. Makes sense? Plus 1 by 1 plus a square root of 5 by 2. Makes sense? 2 will go up. So 1 plus a square root of 5 by 2 plus 2 by 1 plus a square root of 5 by 2 whole by a square root of 5. Okay, if I multiply, then it will become 1 plus the square root of 5 whole square. That will become as 6 plus 2 a square root of 5. 2, okay, and then this side 2 to 4. 4 by 2 into 1 plus a square root of 5 into a square root of 5. Makes sense? 2 a square root of 5 and in bracket 1 plus a square root of 5. Numerator is coming as 6 plus 2 a square root of 5 plus 4. I think so, yeah, 4. So 6 plus 4, 10. 10 plus 2 a square root of 5. Makes sense? Denominator is 2 a square root of 5 and then 1, then 1 plus a square root of 5, I think so. How much it will be? 2 a square root of 5 plus 10, same thing. 10 plus 2 a square root of 5 and denominator is 2 a square root of 5 plus 10. Makes sense? 2 a square root of 5 into 1 plus a square root of 5. 2 a square root of 5 plus 10 only. They cut each other and it become 1. Someone can try for 1 plus 1, b plus 1 by b by a square root of 5 also. It will come as 1 only. Means net it is coming plus b to the power m minus b to the power m divided by a square root of 5. This is what exactly we are expecting on the result side also. A to the power 2n plus 1 plus b minus b to the power 2n plus 1 plus 1 plus, sorry, a to the power 2n plus 1 plus m minus b to the power 2n plus 1 plus m. Okay, this is what we are expecting there, and then plus b to the power plus a to the power m minus 1 minus b to the power m minus 1. Okay, divided by 5. Also we can say as un plus 1 into un plus m, where n is even, m is even, minus um, where n is even, so minus a to the power m minus b to the power m by 2. If I take out, then plus b to the power m minus a to the power m by 2. Exactly same we are getting here also. Okay, a to the power 2n plus 1 plus m minus b to the power 2m plus 1 plus plus b to the power 2m plus 1 plus m. Okay, minus, sorry, plus a to the power m minus 1 minus b to the power m minus 1. That will come un plus 1 un plus m minus, sorry, plus b to the power m minus a to the power m by a square root of 5. That is u minus um. Only thing we did not do is 1 b plus 1 by b by a square root of 5 will be 1. We'll try. B is 1 minus a square root of 5 plus 1 by 2. And then 1 by b means 2 by 1 minus a square root of 5 whole by a square root of 5. If they will multiply each other, it will become 1 square plus a square root of 5 whole square, 6. 6 minus 6 minus, and then, and up, how much is 1 minus a square root of 5 whole square? 6 minus 2 a square root of 5 plus whole, it will be 10 minus 2 a square root of 5 by 2 a square root of 5, 1 minus, sorry, square root of 5 minus 1. I think it is all right. B is the square root of 5 minus 1 by 2. The square root of 5 minus 1, the square root of 5, they will multiply. Square root of 5 minus 1 whole square. That will be 6 minus 2 a square root of 5 plus whole 10 minus 2 a square root of 5 by 2 a square root of 5, a square root of 5, a square root of 5 minus 1. Okay, if I multiply, then it will become 2, okay, 2, 10. It will become 10. 10 minus 2 a square root of 5. Exactly, sir. Numerator is 10 minus 2 a square root of 5. Denominator is 10 minus 2 a square root of 5. What? Perfect. This is something someone can win PhD. I have seen people taking PhD. I don't know where it is, in India or somewhere, because web does not say where is work for every university. Okay, so someone can prove that for the hybrid Fibonacci number, ui summation ui plus m, where I is from 1 to n, where n is even number, then it will come as un plus 1 into un plus m minus um. We have calculated for n as even and m as even. We'll try one m as odd also. We will see if it really works. Please don't mind supporting us. +91 is the India country code. 9483160661 is their telephone number. +91 is India country code. 9483160610 is the telephone.